Number 3, based on the data in the table above, which of the following correctly predicts the relative strength of the attractions of the zinc 2 plus, calcium 2 plus, and barium 2 plus ions to water molecules in a solution from strongest to weakest, and provides the correct reason? Well, first of all, I want you guys to understand why these are even attracted to the water molecules to begin with. If you think about how water is structured, water looks like this with a bent shaped. And as you can see, well, the oxygen is a lot more electronegative than the hydrogen. So there's that little polarity flow there. So this gains a big partial negative charge. So these positives would obviously be attracted to that negative partial charge that is carried by the oxygen. So that's why they're being attracted. So just understand the idea of the attraction. So now, which one is going to be basically, the question is asking for the strength of the attraction. Well, if you think about how strong the attraction is between two atoms, well, there are mainly two factors that you have to think about. Number one, well, how big are your charges? So which in this case, they are all 2 plus, versus if something were to have like 3 plus, like aluminum, or if something were to have like silver, just +1, right? So how big is your charge definitely matters, which in this case, we can't really use that as a basis to figure it out because they all have 2 plus. The next thing is the distance. The closer the distance it is between the two ions, well, the stronger the attraction it must be. And the farther apart, well, the weaker the attraction should be. And this is quite easy to understand. If you just think about the idea, I don't know, let's just say like you're in a relationship. I mean, if you're in a long distance relationship, I mean, you're probably less likely to be attracted to that relationship for a long term, versus if you're like literally right next to each other every day. I mean, you get to see each other every day. I mean, that relationship should be a lot stronger. I don't know. So in terms of the relative strength of the attraction between ions, the two main things you need to worry about are, once again, the distance between the two ions and how big are your charges. So which in this case, I would probably prefer to have something that has the shortest distance to have the strongest interaction. So which in this case, zinc is going to be the clear winner. It's got the smallest atomic radius, meaning how close it is. So let's just say like zinc is right here as compared to the water right here. That distance is going to be the shortest, aka the attraction should be the strongest. So zinc should definitely be the number one guy. So aka we can get rid of C and D. And next one should obviously be the calcium, which has smaller atomic ionic radius than barium does. So it's got to be the calcium. Yep, so they both have, the choices A and B both have the same orders, but let's see what it says. Because the smaller ions have stronger Coulombic attraction to water, absolutely. What does B say? Because the smaller ions are more electronegative is absolutely false, right? When they say smaller ions are more electronegative, that's not necessarily correct, right? Because electronegative just simply means how well it likes to, the ability to pull electrons towards itself, right? And it could be true if you're talking to me about like the halogen families. Fluorine is a lot more electronegative because it has a lot smaller atomic radius than the other halogen guys. So that is true for the family of the halogen family. But if you're talking to me about like alkaline metals or alkaline earth metals, which are all like metals who like to give away electrons anyway, choice B is not necessarily true. And even if it were to be true, that's not what explains this particular scenario here. Like we're basically talking about how strong the attraction should be, and that's why it should be answer choice A. Now, when they say Coulombic attraction, they're talking about the Coulomb's law, which if you need some reviews on it, well, Coulomb's law basically says force due to charge is equal to K, the constant, Q1 and Q2, which is the charge of the first particle and charge of the second particle, all over R squared, R representing the distance between the two ions. So that's what they mean by the Coulombic forces.